Welcome to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. Information about it can be found at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. The lifetime of a light bulb has density function f, where f of x is proportional to x squared divided by 1 plus x cubed, for x between 0 and 5 and 0 otherwise. Calculate the mode of this distribution. The mode is defined as the value of x where the density achieves its maximum, which in this case has to be the value of x where x squared over 1 plus x cubed for x between 0 and 5 achieves its maximum because the density and x squared over 1 plus x cubed are proportional to each other. So how do we look for a maximum of a function? Well, we just take the derivative of it and then see what happens, because we may need to take the second derivative to prove that it's really maximum, or we can just evaluate the first derivative and see how it changes. So the derivative of x squared over 1 plus x cubed with respect to x is the derivative of x squared, which is 2x, multiplied by the denominator 1 plus x cubed minus x squared multiplied by the derivative of the denominator, which is 3x squared, the whole thing divided by the denominator 1 plus x cubed squared, by the rule about the derivative of the ratio of two functions that you learned in calculus. Then we multiply out the things that we have in the numerator, and we cancel them out a bit to the degree that we can, and we end up with 2x minus x squared divided by 1 plus x cubed squared. Well, this derivative is equal to 0 when 2x minus x to the fourth is equal to 0, and that happens when x is 0 or x is equal to cube root of 2, which is approximately 1.25992105. And we also see that for x less than that cube root of 2, the derivative is positive, which means that between 0 and cube root of 2, this function is increasing. And for x more than cube root of 2, the derivative is negative, which means that between cube root of 2 and 5, this function is decreasing. And that means that if you go up and then you go down, the point where the derivative is 0, in this case, is the point where you have a maximum. So that point, the cube root of 2, the value of x, is the mode of the distribution, and cube root of 2, cube root of 2 is approximately 1.26, and that's the mode of the distribution that we're looking for, and that's answer C. Please remember, this is copyrighted material. The problem itself comes from a Society of Actuaries, but the solution is mine. Good luck in your studies and good luck on the test.